All right, good morning, everybody. Today we've already had the Code Forces contest, but I also found out there's this Leetcode contest going on today. I've never done Leetcode before. I just signed up for an account, so now I have one. I have no idea how the submission system works or anything like that, but I decided since it's only an hour and a half long, I might as well take a look at what's going on and maybe compete. So I guess if you're seeing this video, that means I took a look at what was going on and liked it. And if you're not, that means I didn't like it. I thought the problems were boring or something like that, so I just skipped it. But yeah, I see there are some people who are actually like good programmers who tried this, so maybe it's worth trying. This just says don't cheat, right? Okay, so you have a 5-minute penalty. How do we see the problems? Oh, I'm not registered. Okay. Hello. Am I registered? Registration failed, because maybe I'm already registered. I have a notification. Alright, what's going on here? So far, my initial impressions of this site are not super positive. Where are the problems? Here are the problems. Okay. 3, 4, 5, 6. Alright, given a matrix of 1s or 0s, return the number of special positions. A position is special if it's 1 and all other elements are 0. Got it. So we can do this in linear time. Oh, awesome. And they give us this too. Okay, alright, alright. Is the matrix square? Presumably. Okay. Okay, this is gonna get annoying. Let's try just putting this in Eclipse. There we go. All right. So I think this should be fine. Yeah. What's going on? Are we pressed run code? Unknown error. I don't know that I like unknown errors. Please try again in a few seconds. I had an unknown error. What's going on here? Does this compile? It compiles. My answer is 1. Well, what does this look like? Yeah, so it should be 1. Okay. Submit. So I guess, well, now I'm in, so I'll compete. That was a boring problem, but let's see. You're given a list of preferences for n friends where n is always even. For each person, this contains a list of friends sorted in order of preference. In other words, a friend earlier in the list is more preferred than a friend later. Friends in each list are denoted by 0 to n minus 1. So we have n permutations, I think. all other friends are divided into all the friends are divided into pairs. However, the pairing may cause some friends to be unhappy. X is unhappy if X is paired with Y, and there exists a friend U paired with V, where X prefers U, Y prefers V. Okay, I see. And is up to 500. Yeah, okay, interesting. So, what are we supposed to print? The number of unhappy friends. So for each friend, we can iterate through all other friends. So that'd be our n squared. We want to see well, we can just do n cubed even, right? So how does this work? So we've got so if you can like do a swap, that's what makes them better, right? So X prefers U over Y. So you've got X and Y. X prefers Y. U prefers so X and U prefer each other over who they're with. Yeah, you can do this in n squared, I think, even. So n cubed is just even slower. That should be fine. So we can check all pairs that we're matched with. Okay. So for int, well, okay, so we'll do some count. I'll return that. So then for int person 1, okay, so now we want to find the index that they're currently matched with. So int matched with 1, or I guess cur1 will be index of. Oh, I guess, yeah, this is annoying. Okay, so now int array matched with equals int array n. So pairs is something by 2 or 2 by something? Something by 2, it looks like. So matched with at pairs at 0, 0 equals pairs at I1. So now I know who each person is matched with. Okay, so now int first occur will be the index of matched with at t1. And the same thing for whoever the second person is matched with. All right, so yeah, okay. So we have the index of each person in the preferred matching. Now we want to see what if they swap. So let's see, does this even like come close to being right? Compile error, what? Yeah, okay. First. Accepted, okay. Min cost well-connected points. You're given some array points representing integer coordinates of some points in a 2D plane. The cost of connecting 2 points is the Manhattan distance between them. Return the minimum cost to make all points connected. So MST, how big is N? That is so lame. This is a terrible problem. This is so boring. I'm not even gonna do it. It's literally just do MST. Why? Who finds this an interesting question? This is just stupid. It's literally just do MST, isn't it? Why would they even say exactly? That just gives away the answer. Just say at least one. It is a stupid problem. Okay, anyway, let's try this one. Check if the string is transformable with substring sort operations. Given 2 strings s and t, you want to transform s into t using the following operation any number of times. Choose any non-empty substring s and sort it in place in ascending order. Return true if it's possible to transform s into t. Return false otherwise. So you can swap any adjacent pair if there's an inversion with them. So basically you can move an element up as long as you never pass something that like would be bigger than it, or would be smaller than it. You can't ever, like, if you've got like a 2 and a 3, they can't ever switch positions. But anything else you're allowed to do. Only contains digits 0 through 9. So they also have to be anagrams, so we can check if they're anagrams really easily. This one's not a terrible problem. This is like not terrible, yeah. The first one, this is boring. The second one was boring. And the third one is terrible. This is not terrible, I think. Yeah, okay. So they need to be anagrams. That's easy. So now let's say they are anagrams. There are only 10 digits, which sounds abusable. Maybe we don't even need it. Let's use it for now. You've got 10 digits. we want to see, does any digit need to move to the right? Well, moving to the right is fine. Yeah, moving to the right is fine. But we can greedily say what position something would need to get put in. So we can say, yeah, we can greedily assign each element to its position. And then we just need to see, does, do you cross anything bigger than you in the final string? I suppose you just have, for each position, you have 10 things that cross there, right? So you just need to say what happens. Maybe let's think about it for a bit. So if you have 1, 2, 3, 4, go to, well, that's a bad example, I guess, but 2, 1, or 3 maybe. Maybe we go in the other direction. So you want to see, does this 1 ever get passed by something that's bigger than it? So everything that's bigger than it needs to start, that starts on the left, needs to stay on the left. And everything that's bigger than it that starts on the right needs to stay on the right. So we just need to say, does anything cross this position if we go from biggest to smallest? I guess it's not even really cross this position though. It's cross the 1, because the 1 moves. What if we did like an LIS thing? Like that. This isn't super helpful though, because now you can have stuff not match. So maybe that's not a good idea. So now, yeah, okay. How do you actually do this? Maybe I'm just not seeing something obvious. So we want to see if everything, like, is it topologically sound? So this is allowed, right? But we can't go backwards. Maybe it's smart to go from left to right instead of by number. So if we go from left to right, we have limits on the leftmost position each thing can reach, and also the rightmost position each digit can reach. So if we have a 1 cannot reach anything, or there are no limits of the rightmost each thing can reach. But okay, anything bigger than a 2 can't go left of the farthest right 2. Anything bigger than a 4 can't go left of the farthest right 4. Yeah, okay, so that's the idea. So yeah, so we, like, the idea is like verify anagrams. Once we've done that, we can like find the position each maps to. And then once we have that, then we do a sweep, left to right sweep. Okay, so char array S sorted equals s dot to char array, t sorted equals t dot to char array. Then arrays dot sort both of them. S dot length is not, or okay, S sorted dot length not equal to T sorted dot length, turn false. Okay, so now they're anagrams. So now we need an array of positions. Yeah, okay. So we can do an array of stacks. Okay, so now we have all of these for int I equals 0. Let's make an n. Okay, so I is less than n I plus plus. We want the positions of t in this. So positions at t at I minus the 0 character dot add this position at last. Int array map 2 equals new int array n. So now map 2 at I equals positions at s at I minus the 0 character that removed first. And now we have the mapping. Okay. So now we do this L to R sweep. So int array L bound equals new int array 10 for int I equals 0 as less than n I plus plus. Okay, so now we need to see what this maps to. Okay, so int val will be s at I minus the 0 character. Int 2 will be map 2 at I. So now, if 2 is less than L bound at val, then it's impossible. And if it's never impossible, then we can say that it works. We just have to update L bound here. So for everything bigger than us, everything bigger than us or smaller than us? Yeah, anything bigger than us can't go to the left of 2. For int j equals val plus 1, j is less than 10, j plus plus, L bound at j equals mat.max, L bound at j, or the position it goes to. Yeah. Okay. Sounds plausible at least. And this is kind of annoying how this system works, but I guess that's not the end of the world. I hope they let me rename these variables. It's hard to imagine why they wouldn't, but we'll see. Okay, I say true. The answer is true. Let's try submitting. Got it right. All right, what are my thoughts on the contest? It was all right. This problem was good. The rest of them were not great. This one's absolute trash, but I might as well just do it because, like, I might as well solve set. So we'll try it. The fastest way for me to code MST is to use, I don't know if it's prims or Kruskal's, I forget who invented which algorithm, but the one that uses a disjoint set where we sort the edges by value. Nope, not geometry. We want the disjoint set. Then let's get this method signature here. Okay. So static class edge implements comparable edge ij and then the cost. All right, so we have all of these. Now we just construct them naively. And we want to make this edge. So edges at n++ will be new edge from I to j. The cost will be math.abs points at I0 minus points at J0 plus math.abs of points at I1 minus points at J1. All right, arrays.sort the edges. Now we need a disjoint set ej equals new disjoint set size n for edge e and edges. We also need our answer. 0, return the answer. If dj.union, oh, it's got to be an int. Okay, fine. If union e dot I to e dot j, then int plus equals e dot cost. We say 20. The answer is not 20, it's 18. Am I misunderstanding the problem? Am I sorting these? So we can only draw edges between nodes, right? Yeah, okay. Oh wait, it is 20. So let's just submit. Yeah, okay. So that was kind of stupid. I did solve the problems in the contest, right? an hour left. Is there like a scoreboard here? Yeah, okay. So he finished in 10 minutes. What is my finish time? 23rd place. Yeah, I guess maybe sure it's 23rd place, but like I don't know, this is like a good thing to be competing on. Like I don't know, this was a good use of my half hour of time, to be honest. This is Nick Wu, I believe. Yeah, what is this? Oh man, it's got lots of submissions. All on Leetcode. Interesting. Yeah, so they've got a rating system, so maybe that's like one reason to maybe consider doing it. I don't know. I guess, yeah, so like, I'm not like super convinced this is a good use of my time. Might be a better use of time to just not do these at all. I guess let me know what you think. If this is like really entertaining or helpful or something, then I might continue doing it. But to be honest, these problems were unimpressive and not fun. Like this problem was just boring. And then this third problem was like just the most boring classic MST that exists. So as far as like a thing to spend, like I guess sure for practice for like an interview question, which is I think what this is more targeting, maybe it's not terrible because interview questions do show up and they're that like formulaic, like they're that just like this is what every interview question looks like. But it's not fun. If you're a competitive programmer, that's not like, it's fun to do an interview because then you go into the interview, you crush the interview, you have fun with the interviewer, you talk to him with cool problems, stuff like that. But if it's not an interview, if this is just what you're doing for fun on a Saturday evening, I don't think this is the problem I would be solving. I would want to do stuff that's harder and more interesting, because this is the kind of stuff where like I think you can just look this up, right? Like if you know this is an MST, you can look up how to do an MST, and they tell you the formula for Manhattan distance. So like it's just knowing what it is, which is pretty basic. So I guess that's my opinion on it. Is it fun? I don't know. The last problem was cool. The one that was supposed to be the hardest was interesting. I don't like the format. I like to just have my whole solution myself. But maybe it's just because I'm used to that. But, alright, well, I don't know if I'm going to publish the video, but if I do, thanks for watching. Hope you enjoyed. And I don't know, I guess let me know what your thoughts are on Leetcode. Is this something I should do? Is it not worth anybody's time? Is it just even more annoying for you that you're getting notifications about videos you don't care about? What's the story with this? So yeah, thanks for watching. Have a great day and goodbye.